Welcome back. Today we are going to continue our work with properties of equality and do some solving of equations. You will need your workbook and something to write with. We're starting today on page 188. The first half of it is all word problems. I will talk you through those and then have you solve them and then unpause the video and check your answers. And then the last section, there's a couple more problems that I'll explain how to do, have you do them, and then check your answers, and then we'll move forward, okay? Leonardo, do you have anything to say? Hello, camera guy. Okay, is that it? All right, so cameraman, you want to come around? All right, page 188. Number 19 says Bobby wrote y plus 6 equals 15. Then she wrote y plus 6 divided by 3 equals 15. Explain why the second equation is not equivalent to the first. What can Bobby do to make the two equations be equivalent? Okay, two equations. One of them, y plus 6 equals 15. This one, y plus 6 divided by 3 equals 15. So why aren't those equivalent, and what can she do to fix it? Number 20, construct arguments. John wrote that 5 plus 5 equals 10. Nice work, John. Then he wrote that 5 plus 5 plus n equals 10 plus n. Are those equations equivalent? So look at the two. Are they equivalent? Think about what we've learned about how to keep equations equivalent to each other. Number 21, reasoning. Scientists often use a pan balance to measure mass when doing experiments. The equation 4 plus 3 minus 1 equals 7 minus 1 represents a scientist taking away 1 unit of mass from each side of a pan balance. That makes sense, right? Because 4 plus 3 equals 7 minus 1 equals 7 minus 1. Okay. Construct an argument to explain how the scientist knows that the pans are still in balance. So why are those still equal to each other? Okay, number 22. Bryce wrote the equation n minus 3 equals 4. Lexi used a property of equality to write an equivalent equation. Write an equation Lexi could have written. Explain how you know the equations are equivalent. Okay, so he wrote n minus 3 equals 4. And then Lexi used one of the properties of equality to write an equivalent equation. So write an equation that Lexi could have written. So just make up an equation that is equal to this and explain how you know that they're equivalent or equal. Higher order thinking. Emil has $1 and a quarter. Jade has 5 quarters. If Emil gives Jade $1 and Jade gives Emil 4 quarters, will they each still have the same amount of money? Explain. Here's a nice little visual for you. There's Emil's money. There's Jade's money. Okay, 24, vocabulary. If 7w equals 49, which property of equality was used to find the equivalent equation 7w divided by 7 equals 49 divided by 7? So which one of those properties? Addition, subtraction, division, or multiplication? Okay, 25. You start with the equation 12b equals 24. What step should you take to find the quantity that equals 4b? So if you know 12b equals 24, what could you do to figure out what 4b equals? And which property would you use? All right. Pause the video, read those over and solve them, and then unpause it when you're ready to check your answers. All right. So for this one, Bobby wrote y plus 6 equals 15. And then she wrote y plus 6 divided by 3 equals 15. Well, of course they're not equivalent. This one, she divided this whole amount by 3. So if she wanted to make them equivalent, she would need to divide the 15 by 3 also, right? Because if you divide one side by 3, you've got to divide the other side by 3 as well. Okay, Number 20. Are the equations John wrote equivalent? Yes, and they are because he added a variable that has the same value to both sides. So if you add the same amount to both sides, it's still going to be equivalent. All right, number 21. They were equal to begin with, and he changed them both by the same amount. So, of course, they're still equivalent. Number 22. So, n minus 3 plus 5 equals 4 plus 5. So up here we had n minus 3 equals 4, and then I just added 5 to both sides. So if it was equivalent, if this was equivalent and then I did the same thing to both sides, it's still going to be equivalent. And you could have added or subtracted or multiplied or divided anything as long as you did the same thing to both sides, it would be a right answer. Okay, number 23, yes, they would still have the same amount of money because they exchanged the same value, just in different forms. One of them gave $1, the other one gave 4 quarters. It's the same amount. So they changed by the same amount. They still have the same amount of money. All right, number 24, he was using the division property of equality because they, divided. Okay, number 25, you start with the equation 12b equals 24. What step should you take to find the quantity that equals 4b? Well, if you started with 12b and you want to get to 4b, you got to divide by 3. So if you divide both sides by 3, you'll get 4b equals 8. And bonus points, you get 57 bonus points if you can tell me what b equals. Well, let's see, if 4b equals 8, then if I divided both sides by 4, I would get b equals 2. Okay, 57 bonus points. Now, next section, which equation is equivalent to n plus 4 equals 11? Ugh, I accidentally showed you the answers. Forget what you saw. Okay, here, one of those is equivalent to n plus 4 equals 11. Which one is it? Which of the equations is not equivalent to 8p equals 12? Same thing. Look at those and find the one that is not equivalent. Pause. And D. N plus 4 times 2 equals 11 times 2 is equivalent to n plus 4 equals 11. And you can see why they were changed in exactly the same way by the same amount. So they're going to be equivalent. And for number 27, letter B, this is not equivalent. Okay? All right, let's take a look at page 189. So we've got our word problem here. A group of students were on a school bus. How many students were on the bus before the last stop? Now, what information did they give us? Well, we know that the last stop, the bus picked up 16 students. And we also know that the bus arrived at school with 25 students. So what's happening here is there's a certain amount of students that were on the bus that got picked up at, this stop and that stop and the other stop. And then finally they get to the last stop and 16 more students get on the bus. And then it arrives at school with 25 students. So the question is, how many students were already on the bus when they got to that last stop? And what would that equation look like? What do you think? Well, if you said that equation would look like x plus 16 equals 25, you're right. Give yourself a pat on the back and another 14 bonus points. Okay, so x is the number of kids that were on the bus as it was picking kids up. Then at the last stop, it picks up 16 more, and now there are 25. So how can you solve this equation? We want x all by itself, right? Right now it's x plus 16. So if we subtract 16 from this side, then we'll get x all by itself, But we know because of the properties of equality that you can't change one side of an equation without changing the other side by the exact same amount. So if I'm going to do that, I have to subtract 16 over here too. Now let's see what I've got. This cancels that out, so now I've got x equals 25 minus 16, which is 9. So x equals 9. So there were 9 kids on the bus when they got to the last stop, picked up 16 more, and ended up with 25. All right? And I almost showed you the answers again. Here we go. Focus on math practices, reasoning. How does using cubes on the pan balance demonstrate the addition and subtraction properties of equality? What do you think? Well, I'll tell you. To keep it balanced, you have to add or subtract the same amount on both sides. And by doing that, it shows you that they're still balanced. Yeah? Okay. Let's take a look at page 190. So on 190, it shows you 3 different ways to solve these problems. George had some plastic figures. Good for you, George. After he bought 7 more figures, he had 25. This is just like the bus one, right? How many plastic figures did George have before he bought more? So this is just like the bus. The 7 more is the 16 kids who got on at the last stop, right? Having 25 after he bought them, that's like the kids when they got to school. So how would you set up that equation? Let's start by looking at the equation. N plus 7 equals 25. And then you go ahead and solve it. If you subtract 7 from both sides, you get n equals 18. And then if you want to check it, just substitute it in there. If n equals 18, 18 plus 7 is 25. It checks. George started with 18 figures. So these are just other ways that you could do it, a little less convenient. But, you know, if you happen to walk around with a pan balance in your pocket, you can just whip that out. And, oh yeah, you also have to have a bunch of cubes in your pocket, so hopefully you have that. And you can find the value of n by getting it alone on one side of the equation. So you've got this n block, and then 7 more. Take those away and take 7 away from that also, and you'll end up with your n block and 18 cubes on this side. The bar diagram too. N is the unknown amount. 7 is the amount we know, because he bought those, and 25 is the total. So n is this amount you have to figure out. And then you just end up using an equation again. Okay? All right, try it. You have to say it that way, right? So Cabrini had some markers. After she bought 12 more markers, she had 16. How many markers did Cabrini have at the start? Same kind of problem, right? Let n represent the number of markers Cabrini had at the start. Convince me, which property of equality is used to solve the equation n plus 12 equals 16? Could one of the other properties of equality have also been used? Explain. So pause the video here, fill this in, write your explanation, then unpause the video, and we can compare answers. All right, so it is the property of subtraction. And note, to find the original amount you had to subtract. And here, n plus 12 equals 16. We just subtracted 12 from both sides. You get n equals 4. Cabrini had 4 markers at the start. Okay. That's it for that page. I think we have one more page that we're going to do today. So if you can look at page 191. And let's talk about Clive. Who's Clive? He's just a guy in the book. It's a silly name. It's a perfectly fine name. Clive. All right. So Clive is 19 years younger than Josh. Clive is 34. Write and solve a subtraction equation to find out Josh's age. I don't know why we couldn't just ask Josh. Maybe Josh doesn't know how old he is. I don't know. But here's what we do know. We know Clive's age, and we know how much younger Clive is than Josh. So if you add Clive's age to the 19, because Josh is 19 years older than him, you'll find out Josh's age. This is how that looks in an equation. Y, which stands for Josh's age, minus 19 equals 34. Now, if we want to get that y all by itself, we have to get rid of this minus 19 by doing the opposite of it. If it's minus 19, we add 19. And if we add 19 to this side of the equation, we've got to add 19 to the other side. And then we get y equals 53. Josh is 53 years old, which is kind of an early age to already not be able to know how old you are. It's kind of sad. I'm 53. I know how old I am. All right. So here's another thing. Here, substitute 53 for y to check your work. Okay. See how it works out? Now, example 3. Solve problems using equations. Good. Andy had some basketball cards. After he bought 12 more, he had 48 cards. Are you noticing the pattern with these problems? How many cards did Andy have at the start? Draw a bar diagram to represent the situation. So here's the amount he originally had. That's the missing value. Here's how many he bought, 12. And this is how many he's got now. The original amount plus what he added equals how many he has now. So one way is to write and solve an addition equation. N plus 12 equals 48. Because it's plus 12, we'll subtract 12 from both sides. And we find that n equals 36. Andy had 36 cards at the start. You could also do this with a subtraction equation. You could say n equals 48 minus 12, because he ended up with 48. If he hadn't bought those 12, he would have 36. So either of those methods will work. Try it! Vivian read 14 fewer pages than she was assigned to read. Vivian! What's up, Vivian? She read 60 pages. Not enough, Vivian. Write and solve an equation to find out how many pages P, that means that P is going to stand for that, Vivian was assigned. You said P. Leonardo, go sit over there. You said P. All right, sorry about that. Write and solve an equation to find how many pages P Vivian was assigned to read. Okay, so do that now. Pause the video, and then we'll go over that answer together. All right. So here's what I did. Vivian read 14 fewer pages and she was assigned to read. So oops, I used N instead of P because Leonardo kept laughing. So N minus 14 equals 60. And then if you add 14 to both sides, you get N equals 74. All right. So I hope that's all making sense to you. It was fun to see some of you today in those small group meetings, and I look forward to seeing the rest of you on Friday. Keep up the good work. Hope this is all working out for you. I think it is. She said P. Sorry about him. All right, guys. See you next time. Bye.